Okay, now let's look at example 3. And so we're looking at a previous example. So remember this mapping, right? So this was given by this rule. This was the mapping. And so now we're given, let's say, this vector, okay, vector v. And we can calculate where that map sends that vector. Okay, so now with respect to the domain basis B, the representation of this vector is given by the following. Okay, so that's how we denote it. Okay, oh, hold on. B. So the representation with respect to B of this vector is given by 0, 1, half, 2. So I leave it to you to go back to that example with the bases and verify that. And so the matrix vector product gives the representation of the value of h of v with respect to the codomain basis D. Okay, now remember, was given by, so the representation matrix was given by this. Oh, is that it? Nope, nope, nope. No 0. And then there was 1, negative 1. 2, negative 2. Okay, so recall that. And so what we're going to do is we're going to multiply these together. So the representation matrix with respect to D then, right? So the representation with respect, of what? It's going to be h of v with respect to D. Equals the representation of h with respect to b and d times the representation with respect to b of the vector v. And so this is where the matrix vector product comes in. So then this is going to equal negative a half, negative a half, 1, negative 1, 2, negative 2 times 0, negative a half, 2. And again, notice this here is a 2 by 3 matrix. And this is a 3 by 1 matrix. So notice that the 3's match up. The number of columns here is equal to the number of rows there. So again, that's going to be reported later. I'm just pointing it out. And so now we're going to take 0 times the first column. Plus negative a half times, second column, plus negative a half, or excuse me, plus 2 times the third column. And of course, all we're going to do is simplify that, right? And so we end up with what? Oh, hold on a second. All right, so now what do we end up with? We end up with 3.5 negative 3.5, right? Or, oh, wait a minute. Hold on a second. Did I do something wrong? Hold on a second here. Zero, negative 1/2, plus 4. Oh, wait a minute. Oh, this is just positive 1/2. I'm sorry. Yeah, this is positive 1/2. Oh, okay, so this is positive and this is negative. Oh, okay, so this will be negative 4.5. Oh, sorry. Positive, negative. There we go. That's where we should get. Which then this would be 9/2, negative 9/2. Oh, obviously with respect to D. And notice we get a 2x1 vector. Now to find h of v itself, not its representation, all we have to do is take 9/2 times the basis in D, right? So now all we have to do is take 9 to find h of v. That's going to be 9/2 times what? It's going to be the basis in D, which we were told is 1 plus x, plus negative 9/2 times what? The other vector, which is negative 1 plus x. Okay, so if we simplify this, that's going to be 9/2 plus 9/2 x minus, or no, plus 9/2 minus 9/2 x. Well, 9/2 minus 9/2 cancel. This is going to end up doubling, so you get 9. So h of v is 9. that's it.